double check everything's working all right. And we should be going live any second. I need to actually check over here so I can get the stream up. And okay, we're just double checking everything's live, guys. All right, it seems like we are. Cool. All right. What's going on, guys? I hope you can hear me all right. Apologies if there's a fan by there because it's like 30 degrees or 32 degrees right now in my my home office. Yeah, so apologies. Hopefully you can't hear it too much. It's not really coming up on the thing. So I'm sitting down for this workshop, and the reason that I'm sitting down is because I slept funny and done my neck in, so I can't tilt my head. Basically I'm sitting down so that I can rotate, right? So in future I'll be standing up, and just general presentation might be a little bit better. What I need to do is, okay, I need to turn off notifications on my on Slack. Hopefully right. Mute tab. Slack notifications will be just going crazy otherwise. All right, guys, so I just apologize for that. All right, so a couple of things. This is the first workshop that we're doing out of several. We've got 6 lined up, and essentially what we're going to do is we're running a hackathon, right? I'm just going to start the slides, because otherwise I'm just going to start rambling, and we can just get straight into it. If you guys have any questions or comments or anything, just pop them in the chat. I'm going to try and keep an eye on it, but it's on a different screen, so I might miss things, but pop things in the chat, and hopefully Alex, who should be tuned in as well, should be available in the chat. He'll just give me a little nudge without giving me a Slack notification. I'm going to have plenty of water while I do this talk, because like I say, it's about 32 degrees in my office. And with that, I'm going to get started over here. So hopefully you can see this slide. I'm just going to make sure actually watching the thing. Okay, I think we're good. So yeah, it's basically VeChain. We're doing a hackathon. It's open to everyone in the community. And in the lead up to the hackathon, we're going to be doing a series of workshops. We've got 6 booked. This is the first one, which we're going to be looking specifically at smart contracts and the blockchain development side of things. Then as we progress through these workshops, we're going to start introducing more VeChain specific. Oh, I popped myself in the bottom down here, I think. Apparently I can't. We're going to start introducing more VeChain specific tooling. There we go. More VeChain specific tooling, like introducing backend development, working through integrating these contracts into a functional dApp. And so that's basically what's going to be going on with these workshops. I'm so thirsty. Sorry, guys. This is going to be very interrupting. So we're going to start with blockchain stuff. But before I get started, we're going to actually have a little look at some of the these slides. We're going to talk about the hackathon, what's going on with it, to kind of introduce what's actually happening, because you'll probably watch this in the future and actually want some of this information because it is obviously relevant. So if I click over here, in case you didn't already know, I'm at the end. I'm right at the end, typical. In case you didn't know, my name's Reese, Stoic VeChain on X, and I'm the DevRel at VeChain. And I've been with VeChain for a while now. It feels like a lot less time than it actually is. But basically, one of these things that we've been doing is working on building out this hackathon with all this educational content that can help improve the development experience, to kind of onboard people who are interested in developing on VeChain but don't have the kind of knowledge or don't really know where to get started. And so as we build up to this hackathon, the goal is for these workshops to incrementally introduce more of these concepts to help take you from like interested in developing on VeChain to building and deploying dApps during this hackathon. Okay, so the workshop plan, we're going to be having a look at some very, very simple blockchain stuff. We're going to have a look at contract structure and some information about how smart contracts work and how they're structured and organized. We're going to have a little bit of an introduction of VBeta integration, because that's very, very relevant to what we're doing in the hackathon. And we're going to have a look at like kind of compiling and testing smart contracts as well. These things, a lot of information on this kind of stuff does exist, but it's very kind of disparate and all over the place. However, there's only so much time that we can actually cover. There's only so many things we can cover with the time we got during this workshop. So what I would suggest doing is one of my colleagues, Dan, did, well, it wasn't just Dan, there was someone else as well involved, I believe, did a series of much, much more in-depth videos on developing Solidity smart contracts on VeChain specifically. Definitely go and check them out. They're on this YouTube channel, so you should just be able to search through the videos and find them. It shouldn't be too difficult for you. But what we're going to do here is a very, very basic look at smart contracts with Solidity. I mean, Solidity is the smart contract language that we use on VeChain because it's an EVM chain or EVM compatible. And we're going to kind of go just through the process of building and answer some questions and kind of see, yeah, kind of help get people started. The screen's over here, sorry. So if I'm looking over here, I'm not ignoring you. Okay, so I'm going to have a little swig of this. So, about the hackathon. So the hackathon that we're doing is going to be running for, it's only 2 weeks, running from the 22nd of September until the 6th of October. And it's going to be, as it says here, you can join online. And we're focusing on development mostly to do with VBeta, obviously, and building kind of sustainable apps and things like that, right? We do actually have several different tracks, which I'll get to just in a second. But ideally, we're looking for team sizes of 2 to 4 people who can build and who can build some interesting things on VeChain. There is, like I say, we're going to be doing all of these workshops leading up to it, and we're going to have as much education and kind of supporting content out there for people to help guide them through this process. All right, we've got a lot more information coming over the next couple of weeks as we do more and more of these live streams. So just subscribe to the YouTube channel if you're not. Check out the Discord, check out the VeChain Builders Telegram and Twitter account or X account, and just tune in when you have a chance. These are obviously going to be live streamed, but I mean, the advantage of a live stream is you can also watch them later if you want. Okay. So the hackathon prize pool, we have 30k USD that we're giving away in prizes over 3 different tracks. We're going to be giving it away in VET to eligible submissions. And like I say, there are these 3 different tracks. So the first one is VBeta apps specifically. So it's sustainable development goals of VeChain is pushing towards VBeta. Excuse me. We also have a kind of miscellaneous track for apps that don't really fit within the parameters of like a VBeta app, but are working towards the same kind of sustainable development goals. And the last track that we have, the third one, is interoperability and tooling. And we're actually going to have later on in this series, we're going to have a workshop with VeChain talking about their tooling to help get you guys started if that's something that you're going to be interested in pursuing for this hackathon as well. Okay. Before we start, there's a couple of little things. I've kind of already mentioned this very briefly, and that is add your questions in the chat. We'll try and get to them as much as possible, but it's just me here, right? So I've got some of the guys checking this out live and keeping track, so they're going to try and pipe these questions to me so that I don't miss out on them. But if we don't have time to actually get through them, or I miss some of them, I'm sorry. We're going to try our best to get as many of these things answered as possible. And also, terms and conditions and the hackathon guide, as it says here, is on academy.vchain.org/hackathon. So for more information, the terms and conditions and the kind of guidelines for the hackathon, you can go and check that out at that URL on academy.vchain.org. Okay. All right, let's get started. I feel like that's kind of a necessary slide. Let's get started. Guys, it's going to be quite informal, all right? Sorry about that. So, blockchain. Blockchain is basically just a record of actions. So a transaction is used to sign to kind of commit a change to the chain, and then that's recorded as an event on the blockchain, and it's immutable, right? It kind of persists forever. So what the blockchain actually is just a record of actions throughout the lifespan of that chain. And this has obviously got some very advantageous kind of things that you can do with it, because things can't be changed retroactively, right? So you can't go back and, oh, I've done something wrong, I'm going to go back and change it, or I want to hide something or obscure something or whatever, you know. And so it's, once something's done, it's fixed, it's obviously public, and it's just open for A, for people to take part in, but B, for people to use as a way of validating that they have either permission to do a certain action or to take actions on chain for, you know, whatever reason. And we're going to, when we're looking at these kinds of actions, we're going to specifically be looking more at smart contracts than what blockchain is, because you guys just being here, I'm going to assume you have some understanding of what the blockchain is, or how it works, and generally kind of how things operate. But smart contracts are essentially functions that live on chain. They're like little computer programs that you can interact with that have a predefined set of rules to either read or write or emit some kind of event as actions take place. So as you can see here, it says calling a smart contract function has these 2 points. There's an ice cream van outside. I'm going to close the window. He obviously knew that I was live. Yeah, so essentially, smart contracts are basically programs that we deploy on chain to enforce certain rules and allow certain actions to happen without the need of someone to be sitting around and checking all the time, right? Because imagine, for example, we have this right example is to mint an NFT. Imagine if we were going to build an NFT project and we didn't utilize smart contracts to do so, right? Let's just picture this, and we can maybe understand a little bit more, like a real example of why smart contracts have these advantages. So I'm making an NFT project. I mint, you know, 100,000 tokens, or just 100 even, just 100 tokens. And then I say, you know, if you guys send me 10 VET, then I'll send you an NFT. All right, that sounds good, you know, reasonable, whatever, it doesn't really matter. But what that means is I would either need to spend all my time sitting there watching my wallet for certain actions to occur and then react accordingly. So I'd have to sit there and wait for someone to send me 100 VET, and then I would send them out an NFT, right? And you think, oh, that wouldn't be too bad, you know, if there's just 100, but what if there was 1 million? It becomes a bit more of a challenge, right? And what if someone sends you the slightly wrong amount, or what if someone sends you 2 times that amount, or, you know, like there are all these kinds of things that you need to be present for at all times until you've sold all of your NFTs, right? So this is a problem because it forces the person who's working on that, I mean, we'll just call it a business for argument's sake, but whoever's building that business then has to spend their entire time sat in front of their computer or their wallet to be able to act on these kinds of things whenever they're available, right? Whenever something happens, it's a consistent reactionary, you basically give yourself a job, whether you're making money or not. And that's just not, it's just not a sustainable way to operate, obviously, right? So we need to have ways that we can enforce specific actions, like we only send out an NFT if you send me 100 VET, but we also need to be able to say, do it automatically, right? I don't want to be there all the time making sure that NFTs are sent. We can do it in one transaction even, and we can record information to the chain automatically. We don't need to take part, right? And this is kind of where smart contracts fit in. And an NFT, you'd say, oh, maybe that's quite a simplistic example, but even for the most simplistic actions, it's usually better that you don't have to spend all the time sat in front of your laptop waiting for certain actions to occur, right? Like it's just common sense that we would want to try and automate these things as much as possible. And smart contracts really help us do this because we can write programs that define a set of rules that mean we can have more flexibility in the kinds of things we can do. And this will allow us to do a lot more on chain automatically, but also allow people to interact with it in different ways that kind of give other information about what's happening. And this opens up a whole world. You know, in the case of NFTs, it's not like that exciting. You're either buying an NFT or you're selling the NFT, right? There's like two actions essentially. But when you come to something a little bit more complex, it's really handy to be able to define something almost like how you would define API endpoints. You could kind of think of it as something similar, and you have all of these different endpoints, and depending on what kind of requests you send, right? Think of like a basic CRUD app. You can write to a database, you can read from a database, you can update information at a database. And this is like the basic kind of functionality that we're enabled with smart contracts, but we can do it on the blockchain. So it's immutable, it's enforced, and there's no manipulation of it essentially. Okay, so that's a very long way to go around what smart contracts are. But when we're building on VeChain, I need another drink, sorry guys. When we're building on VeChain, specifically with dApps, we need to interact with smart contracts in two primary ways. The first one is read operations, and the second one is write operations. Now, read operations, just as you kind of expect, you're reading information from the chain. They don't require any kind of change of state, so they don't require a transaction. They can also be called directly from like a front end with like a simple query to the blockchain, and they don't cost anything because there's no transaction, there's no fee associated with it. So this is something like, imagine you have a list of NFTs, oh sorry, we'll move off the NFT because it's not really a very good example for anything past super basic, right? But imagine we had something like, we're recording some data on chain. You can read that data for free. Right, that's not going to cost you anything. You don't need to sign the transaction. You just query the address or the specific clause, which we'll get onto a little bit later. But that clause from a contract, we can call it, and it will give us that information back. Similar to querying like a database, like you say, get whatever, you know, get requests. And then the opposite of that, the other option is writing. And writing operations are state-changing functions. So they require users to sign a transaction. They obviously consume gas. You know, they have a cost associated with them because you are executing something on chain. And you can do things like trigger event logs and permanent changes to these on-chain records. So if we're having a look at storing some data on chain, maybe adding a new record to that data, or updating a specific record within that those parameters, right? Say, so it's these kinds of operations that then require gas because you're making a change to the state on chain. Cool. Sorry, it's a bit jolty between these slides because I have to like shift focus completely to kind of interact with it. Okay, so as I've already kind of mentioned, smart contracts automate event execution. So smart contracts, it's more than just like code on the blockchain. It says here they're self-executing logic. You can just consider them as on-chain programs. So like some kind of bit of software on-chain that reacts to things that happen on-chain. They change state, or they allow people to interact with them to change state, and they can, you know, provide information. They can store information and obviously then update things accordingly. They're really, really useful, and I mean, obviously they're useful, right? There's a whole industry built on how smart contracts work and running programs on chain to be able to develop things that are kind of decentralized and open to the community to interact with. So a little look at a smart contract. I have some actual code, which we'll look at in a bit, by the way, guys. But this is a very kind of high level. You know what? The syntax highlighting is killing me. The syntax highlighting is killing me. But this is a little look at some information for connecting a smart contract to VBetaDAO. And up the top, at the start of your program, when you're writing a smart contract, you're going to have this license identifier. It says SPDX license identifier, and this is an MIT license, and it has this pragma keyword, which is basically specifying the version of Solidity that you're using in this smart contract. Super simple stuff. Then we have this interface, and this interface defines the rules for interacting with the VBetaDAO, the extra earn rewards pool for the VBeta apps. So that's essentially what that's doing. And we're not really going to talk about this too much right now, because we're going to introduce it a little bit later on when we actually had a look at some smart contracts. But just to give you a very high level idea, this is what smart contracts kind of look like. We've set up an interface so that we can interact with a certain thing, and then interact with something separate to our contract, to our program, right? It becomes like almost like a dependency or an endpoint that we can hit. And then we have our contract down here, your contract, and this particular keyword is kind of like a function, right? So it's like defining your contract function as your contract. That's the name of it. And then in here you say you have your contract code below, right? Within those braces. Okay, so I feel like we can probably skip this one as well. But essentially this is this function here is a private function. And a private function means that it's not public, so not everyone can actually execute this function, right? Call this function, or call this like API endpoint. I feel like an API is quite a good analogy, that it makes it very simple for people who aren't familiar with blockchain to understand how that you interact with these things. So we're just going to run with that. I know it's not an API, right, guys? So anyway, here we got a function called distribute rewards. It's private, which means that it's not public facing, so not anyone can just query it or try and execute it. It requires that there's a greater than 0 reward amount. It requires that there is some funds available, some rewards available in the rewards pool for this contract. And then it checks whether an action's valid here. This actually you need to do, right? This is where this code goes. But there's a couple of really key things here. And the main one really is that each smart contract has individual functions, right? Individual endpoints. And so realistically, if you think about the structure of a smart contract, you can kind of compare it to how like a class works. So you have your class is your contract, and then you have these individual kind of calls or functions or methods that you can call through this point, through this class, to be able to execute certain functionality built within it. And so actually maybe that's quite a good way for comparing how you would think about structuring or designing a smart contract. Cool. The other thing that was quite important here, which I almost forgot to mention, is this require keyword. So you can think of a require, it's basically like a Boolean check. And so it's saying that if the amount is greater than 0, it returns true, and then you can do whatever you want. And if not, it just errors and returns the reward amount must be greater than 0. All right, it's a very, very simple kind of check. You can add much more complex logic in these required kind of statements or functions, which, as you can see here, we've got something that's slightly more complicated, where we're saying the reward amount is less than or equal to the available funds in the pool, right, for our app ID. Again, we'll get on to the VBeta stuff more specifically a little bit later, but this just gives you a very high level kind of look at what the syntax is for Solidity without syntax highlighting. That's a problem. So don't worry, we'll have a look at contracts in a second. So smart contracts, they're compiled. What that means is you're not exactly deploying the contract code that you write in Solidity, but you're generating an output from that, some bytecode, as you can see here, and this is what's actually deployed on chain. Now, it's not just that. The way that apps and kind of other services, like non-blockchain services, interact with smart contracts when you're building transactions and stuff is using, generally speaking, using an ABI. And aside from needing some more water, the ABI is essentially a very big JSON file and it has it looks like, I mean, the JSON file is basically a list of different objects, and these objects represent each of the function calls that you have within your smart contract. And it just defines the rules for them in an easier to read kind of method, like an easier to read syntax that you can easily interact with from like a front end app or something like that, for example. It just makes it much easier to interact with them instead of having to deal with like random snippets of bytecode, right, which would be a pain. Okay, so like I said, it's a compiled language, which means you need to compile it to be able to deploy a smart contract. And you do that, well, you don't need to use this specific, VeChain has a hard hat toolkit that you can just use, but we're not actually going to use it that in this workshop because it's quite overwhelming if you just use the setup script, but we'll look at it. We'll look at it anyway. But essentially, we'll use Sol-C, which is the Sol compiler, and we have this Buy Me a Coffee Sol snippet as an example. So the Buy Me a Coffee Sol is the Solidity contract, and that .sol is basically the file extension for Solidity files, right? And then when we execute this, when we try and compile our smart contract, we add this EVM version flag, which is Shanghai, because since the hard fork, we're now Shanghai compatible instead of previously it was Paris, I believe. We can also use these optimize flags and optimize runs to be able to try and simplify the code in some way. And I don't know how that works exactly. I think that's like a little bit of wizardry in the back end, but it's supposed to improve how your contracts execute and make them cheaper, right? So give it a go. We output a binary, which is that bin flag. We also output the ABI, which is the ABI flag, and hashes. And the hashes are essentially the I might get this wrong, actually, so you might need to correct me. Guys, in the chat, I've got my eyes on you now. You might need to correct me on this, but I believe the hashes are for the outputs of each of the individual methods. And so then you would use those, or you could use those as a way of interacting with those specific functions as well. Correct me in the chat if I'm wrong about that, because I might be. In here, we also have this metadata flag, and we're overwriting. And what we're overwriting here is our out. Out is what we're defining as the output file for our binary, with that just the O flag. And overwrite means that we're going to overwrite it if it already exists. Okay, so this is a kind of function. This is the kind of terminal, like what you write in a terminal, basically. If you had been compiling this a couple of times, you know, because maybe there was some issue, or because you were running this in parallel with developing your app and you wanted to add some functionality or edit how one of the functions work, you know, just general kind of debugging stuff or integration stuff, then you could just quickly overwrite the file and then use that directly. So you don't need to change stuff on the front end. All right, cool. Right, so before we get into the actual smart contract stuff then, connect with us on X, connect with us on Telegram. The VBeta Telegram is great, or the VeChain builders as well, if you want to have a chat with us guys specifically to talk about the development problems or any questions you have or anything like that. Really do join us on Telegram, because that's a really good place to ask questions and get your questions answered. Join us on X everywhere. VeChain, obviously VeChain official. You can reach out to me as well at Stoic VeChain. And VeChain builders. I think that's everyone. I've definitely forgotten people, guys. Sorry. Just look for VeChain and you'll find a huge community if you aren't already a part of it. Okay. Quick swig. Do we have anything else? No, we don't. Okay, so I mean, that's basically it, right? That's a quick introduction to Solidity. This isn't the end of the workshop, don't worry. We've talked a little bit about how we're going to interact with smart contracts, what they do, and now we're going to have a look at an actual example of a smart contract. When I first started this, the stream, I was talking about having an incremental development process over these workshops, and we're going to be working essentially on an app, right? On the kind of thing that we're looking to have submitted to this hackathon, specifically on the VBeta track. And so we're going to be building a VBeta app that's going to store credentials and certificates of people. And when we were thinking about how we would do this, we were thinking about, because we've been doing a lot of workshops at universities, we were thinking about implementing like a learn-to-earn platform. And so this is the direction that we're going to be going with it. And this is like the general theme of what we're going to be building through these workshops. So every different workshop that we do is going to be, as I've already said, introducing a new concept of development on VeChain into the mix, and the overarching product that we're going to be working on, or the application we're working on, is going to be a learn-to-earn platform. So if we were going to build a learn-to-earn platform, what are the kinds of things that we would need to have in a smart contract, right? If anyone has any questions in the chat, feel free to reach out. I've got eyes on it. I've got eyes on it. So if we were going to build like a learn-to-earn platform, we would need to first off record a record of the students who take any particular course. We would also need to do things like have a record of whether or not students have passed a course, or what kind of gradings they've got, or whether they've registered for a course, maybe because maybe they have to pay to go to the course, for example, and they register. They register, but then they don't quite pay, so they don't quite fulfill the requirements to join on or whatever, register. We probably also want to record information on the institute, right? The people who, or the like university as an example, right? That's teaching this course. And we'd also probably need to have some information about either the tutor or like the registrar, right? The person who has ultimate control over changing student parameters, and is the person actually delivering that course. All right, I'm going to get out of this now, and we're going to start actually looking at things. How do we? Do we just press escape? Yes. Okay. So get me up on the screen again. Guys, this is super zoomed out. Don't worry, I'm going to fix that in a second. We're going to be having a little look at building this smart contract. Actually, that's a bit misleading. So I'm not on my main computer right now. I'm on the Mac. And so I'm using a QWERTY keyboard, and I'm terrible with QWERTY because I'm one of those people who has their own fancy keyboard layout and stuff. So I'm going to do as little typing as possible, actually. But we are going to try and have a look at this as much as possible and introduce as much information and kind of teach as much about smart contracts using this example as a starting point for us to build off. So when we have a look at this stuff, for a starter, there's quite a few little concepts that we want to introduce, even just covering things that we've already spoken about. There's a lot of concepts for smart contracts specifically that are really worth covering in like a short workshop like this. So I know we got like an hour and a half left or something, but we're going to be having a look at a very basic kind of contract structure, data types, and state variables and how we deal with those. We're going to have a look at functions as well, obviously, kind of like we've already touched on. We're going to have a look at events and logging events and emitting events from a contract when certain actions take place. We're going to have a look at access control and how we kind of limit whether or not someone is able to take a specific action or call a specific function in the contract. We're going to have a look at the external integration, which we did actually touch on a little bit with the slides there. The bits without the syntax highlighting. Okay, I'm never going to let that go, by the way. And we're also going to have a look at some slightly more advanced concepts if we have time. I've got a project that kind of already exists here because we've already been through a lot of this stuff. So this learn-to-earn contract here needs to be zoomed in on quite a lot. We're going to get right in here. All right, so we have a contract here. We've got a ton of functions, and it's all done. It's all built, right? So we're not going to work through each of these steps individually because, I mean, how big is this? This is, okay, it's 270 odd lines, so it's not really that big for a contract, but it's reasonable enough that it would be tedious if I just sit there and like, right, come on, no one needs that. But what we can do is we can break down each of these individual parts and talk about them and kind of discuss maybe what could be improved or how we could implement something slightly differently to allow different functionality. Guys, I'm just going to let you kind of go a little bit wild with questions now if you want, because I've got it set up a bit here. I'm feeling like I'm in the flow with it a little bit now. So when we're building smart contracts, there's a couple of different things that we really want to be looking at. The first is like how we start. Let me just do this. Cool. The first thing, which we already kind of touched on a little bit, is how we kind of initialize a smart contract, the kind of boilerplate code that needs to be in your file. And one of the good things about Solidity is there isn't a lot of boilerplate. One of the languages that I used to work a lot in was Haskell, and Haskell is like, there is a ton of boilerplate, and importing things is like an absolute nightmare. And yeah, I mean, just don't really do Haskell unless you absolutely have to, guys. But essentially, we've got, as I've already mentioned, and this will be a bit more legible now. Can I just get rid of this? Command B. Thanks, cursor. I don't use cursor very often. Oh, I only use it for like things like this, really. So you have to excuse me. Can we see that all right? Yeah, I think that's better. I think that's a bit better, isn't it? More like Vim. So I don't want to update, just later. Poor guy. Yeah, so there isn't a lot of boilerplate with Solidity smart contracts, which is a bit of a breath of fresh air, to be honest with you. If you're importing lots of things, so if you're importing different like snapshots of things and stuff, then that might be something that, sorry, if you're importing different modules and stuff, then maybe you need to actually deal with those kinds of things and handle them. But in this example, we're not. It's just going to be one contract all in one. And that is where this contract keyword comes in, which you can kind of consider like a class, right? It's a good comparison, I think. I'm going with it anyway. So this is like a learn to earn class, but we use this contract keyword, which defines the actual contract that you're compiling, right? This is what's going to be compiled when you compile the program. We also have, as I mentioned before, other than this license stuff, we have this pragma, and this, like I already mentioned, is just the version of Solidity that we're using. So if you're building contracts on VeChain, go with this, go this. All right, just take this boilerplate literally and run with it, and you'll be all right. Because Ethereum and EVM in general is a bit further ahead on different features than what VeChain's running, right? Like I mentioned, we use Shanghai. Shanghai is the latest version of EVM that's compatible with VeChain. So I think this is probably a safe one. There might be others we can work with, but I don't know, to be honest with you guys. And maybe someone in the chat has a better idea of that. Okay, but anyway, we define our contract. We call it learn to earn, because that's the kind of thing that we're building. And I've just got this to do in here, which is just add the code to the contract. Super simple boilerplate, very lightweight, but it, as with all kind of boilerplate or like the initialization of any kind of project, it really is just the beginning, right? There are actually, the most important thing that we need to do to really get the contract off the ground is to have a constructor, just like a class would, right? And our constructor basically defines the kind of information that we need to be able to deploy the contract. So let's have a look at that actually. Maybe I'll just pull that back up. And what have we got? We got a different file here that's a little bit more information. So here we have a couple of things, but the main thing that we want to start with is our constructor. And I've commented a bunch of things out here. I'm just going to undo that and undo this. And this might be introducing this concept a little bit too early, but these X to earn and the app ID things are VBeta specific. So when it comes to actually integrating your contract with your VBeta app, this is the kind of thing you would need to be able to do that. All right, so that we can interact with our rewards pool, and we provide our app ID as a variable to be able to pick the app, right, which app we are. Anyway, we'll come to that in a different workshop when we talk more about our VBeta integration, and we actually have done some kind of back-end stuff and some front-end stuff as well. So that's kind of really just wrapping things up. But our constructor is going to set the initial bit of information that we need to be able to deploy our contract. So in this case, the only thing that we really need to talk about is this institute, which I had already mentioned is going to be, like, you can consider this like academy, right? We'll go with that. Like, this is like having the VeChain Academy deploy this as a VBeta app, right, a learn to earn app. And so in this case, it's just a string, right? It's nothing particularly complex. And we could just put, you know, academy or like academy.vchain, right, as that string parameter when we deploy our contract. And that means that if we then try deploying it with a different constructor, the contract will be different, and those two are kind of separate implementations of with the same functionality, but separate programs. Okay. Another thing that we need to do is we need to kind of define the data that we're going to be storing at this place, because if we have this as a learn to earn thing, we need to be able to store information about our students. We need to be able to store information about the certificates, and the kind of information that we need is what we really need to define next. And so we'll start with this struct. Now a struct is, I mean, a struct is probably something everyone's quite familiar with. You could compare it to a dict, you could compare it to an object. It's basically a bit of data, right? It's a definitional bit of data. And this struct has a couple of bits of information that we're going to need. I'm not used to hovering and things popping up, so I need to like keep my mouse over here. So our struct, our student struct in particular, is the information that we're going to be storing on chain. And so if we're going to record students, have them register for our like learn to earn platform, we're going to need to store a wallet so that they can sign transactions to validate things that they've done or commit their own information, and also so that we know who to send rewards to when they're complete. This also has a bit of another advantage, which means that we can check all of the structs for a specific address by checking the person who's signing that transaction and then comparing it to students. So this would prevent people from like registering twice accidentally or intentionally with either different information or anything like that. Like one wallet would only be able to register once with the platform. Other information we've got is this, again, strings. Oh, I didn't actually say this, but our wallet we have defined as an address type. And an address type is a fixed type that Solidity recognizes. So it says here, oh, it doesn't give us information. I thought it was going to. But it's like a predefined type that has some limitations, like the length of it, for example. What is the size? What is the size? A 20 byte is an Ethereum address. I should know that really, shouldn't I, off the top of my head? But anyway, apparently it's 20 bytes, guys. So it's a predefined type, it's a predefined size or data size, which is really handy if we're going to be just loading up arbitrary bits of information. It's good to have some kind of type safety built into that, right? And that's kind of where this address comes in. And it's, as it says here, it's just the student's wallet. It's nothing particularly complicated. We then have two strings. Strings are obviously unlimited, right? They don't have defined sizes or lengths. And so it could basically be anything. But we have our strings as the first name and the surname of the student. Now, when I was talking about this stuff at Goldsmiths last week, when we were supposed to do the live stream. I didn't even apologize for that, guys. Sorry, we had some technical issues with the campus firewall that prevented us from being able to live stream that event, which is why we're doing it this week. But basically, one of the students made a very good point about putting people's personal information on the blockchain. And they didn't, I don't think they quite put it like that, but it started quite a nice and interesting discussion. And obviously this is just an example. But generally speaking, there might be a better way to organize this information to basically protect the students' identities, right? We already have their wallet. Do we also need their first and surname? Probably not. There might be a better way that we could handle this data instead of just putting it publicly available on chain, for example. But anyway, those kinds of things are something that you guys would consider. We're not really going to change this this contract right now, to be honest. But when you guys are building your smart contracts, the availability, public availability of private data is something that you should probably consider and try and work around as much as you can. Generally speaking, like my rule of thumb whenever writing any kind of smart contracts is that you only store things that are absolutely necessary. And so if there's a way that we could, get around actually requiring this information of people, like that would probably be better, like a better implementation. All right, but a bit of a side note, really, it doesn't matter too much for this example. We're going to be storing your first name and your last name as part of this. Then we have this thing that's so frustrating. I'm going to use the keyboard. I'm just going to switch to the keyboard, guys. Yeah, but essentially, like, don't worry about it too much, right, for this example. But I would say that generally speaking, it's better to prevent exposing people's personal information as much as possible. Let's slip that in there. Right, do we have the keyboard in place? Yes, we do. Oh, that's so much better. That's so much better. Now I've lost my mouse. Okay. Get rid of that. Cool. So we've got these two Boolean values here, right? A bool is basically a true or false, right? You probably already know what this kind of stuff is. And essentially, this is going to be true if the student has registered, and it's going to be false if they haven't registered, and then graduated, the same thing. If you've completed the course, then it'll return true, and if not, it's going to be false. And this is obviously a very simple way of kind of storing some data. It's generally lighter than having like integers, and instead, and obviously it's binary, right? It's either true or false. You can't kind of get around that. You can't accidentally put a 3 in, right? I feel like someone's done something like that recently. Anyway. Yeah, so when someone registers, or when someone submits their information, registers as a student, they might not necessarily have registered as on a course straight away. Maybe there's some payment they need to do. Maybe there's a selection of courses that you can register for. And so maybe that would start, like registered starts as a false value. Graduated is obviously going to be starting as a false value, right? There's not going to be, you're not going to be graduating on the same day that you've kind of registered for a course, and you're not going to be registering as graduated either. So obviously that's going to initialize as false. And then the last thing we've got in our struct is a certificate, which is a 32-bit hash. And this is created for this certificate here when the student actually graduates. So that's going to be a proof that's put in at that point. We've also got this event type here, which is certificate issued. And so, like it says here, I put comments all over this, by the way, guys. There's an event triggered when the certificate is issued. So when someone completes the course and it's approved and they graduate, they'll be issued a certificate, which is essentially a proof that they have taken part in this course and they've completed it. So if you think in terms of like a university, this is essentially the same as like having your degree certificate, right? And that's the idea that this is replacing, right? Some kind of immutable version of that. Do you have your certificates? Like, I feel like if you haven't framed them and put them on the wall, they're probably lost somewhere. Not speaking from experience or anything, guys, all right? So we kind of covered a lot of the initializing things that we need for our smart contract now, right? We've got our constructor for when we deploy the contract, and we've defined that with the X to earn rewards. We also have our student struct. You know what we haven't talked about is these two variables that we've described at the top. So we have our institute, right, which is the name of the university, like VeChain Academy, for example. Publicly available, which is why it has this public keyword. It'd be so much easier just using the keyboard. Shortcuts, guys. Keyboard shortcuts are the way. Anyway, we also have this private value here, which again is an address, and this is registrar, right? And so this is the person who, the contract creator, it says up here. And you can think about this as like the person who's deploying the contract, and they are going to have admin rights to this contract, essentially. So they can do things that aren't, like they can call functions. If they sign a transaction that calls a specific function that isn't publicly available, it's private, they should be able to interact with it. Whereas if I deploy it, then you guys, you shouldn't be able to interact with those, right? Because it's going to check, hopefully, it's going to be checking that the transaction signed or the message sender is this specific address, right? My address as the registrar. Okay, so I mean, it's just a name variable basically, but it's given as private. And like I say, guys, these contracts are very kind of similar in structure and like design as how classes work. So it's very, very easy to work with if you're familiar with other programming languages. It's very easy to pick up. Okay, now I need to go back to my mouse quickly. So I'm just going to ignore this, Command B, and we're going to have a little look at events. Now this, I think this is actually bad, right? What I've done this in like the wrong order, but I think it's a nice way to introduce this concept, right? So events are, I think Dan actually in his workshop said it like this, and it's quite a nice analogy. Events are like, they're like console logging from a smart contract, right? So if you have like an application or like some kind of service, back end, front end, whatever that you're building, you can log things to the console, which in this case is like the blockchain, but you can't really read those logs, right? And this is kind of how these events work. When you emit an event, for example, this event's triggered when a proof is submitted, right? You've received a submission for your course, then for pushing stuff out for VBetterDAO, for earning some rewards. These events are emitted automatically, and it's basically like console logging onto the chain, right? The smart contract itself doesn't see this event. You can't look at the history of these events that you've emitted, but what you can do as a front end or as some back end service is basically check, read, and react to these kinds of events. So they're a really useful way of communicating between the smart contract and your dApp, specifically for like read-only kind of functions. I feel like I'm so dehydrated. Okay, cool. So, like I say, I kind of done this backwards, right? Maybe it's better for us to look at functions first, but there are a lot less events that happen than there are functions. And actually, it helps us kind of introduce this other concept, this mapping. And mapping is basically like using one bit of information to as like a key to find some value, right? And so it basically works like this. You're mapping an address to a student, you're mapping an address to a string, you're mapping an address to a bool or an address to a different bool. And it gives you which or variable names for these things. They're all public, right? And what that means, or what you can do with these kinds of things, is just say, I have someone who's sent a transaction or is calling this contract function, and it'll pass over them as a message.sender, right, the sender of the message. And from that address, you can get whether or not they're a student and return that student data, or you can update their student data, or you can check a submission, or you can check if they've been like graded, if they have that Boolean value, or if they've been rewarded. And so it's basically taking incoming data, just like if you were going to, with your API, with your like CRUD app, if you were going to do something like, say, find a record by ID, all right? And in this case, we're using the wallet address, right? The user's address or the registrar's address, but as that ID, and then you're finding the record or updating the record or checking a specific value in that struct, right, in that record. I hope I've explained that very well. I find like, because of the terminology differences, you can get lost by just saying like whatever over and over again, like just bool or something, you know. But that is the mapping, and that's really, really useful because we want to just be able to take someone's transaction and check whether or not they have permission to do a certain thing. Or we want someone to sign a transaction and then take only that one little bit of data, right? Just the transaction signature, just that address or the person who's submitting that transaction, and be able to tell immediately whether or not they have registered as a student, whether or not they need to register as a student, whether they've graduated, and kind of get all that information off chain very, very quickly, all right? And so that's what mappings are for, and that's kind of why I introduced them next. But what we really want to talk about is the functions. Yeah, because functions is really where all the validation happens. This is all great, but this is only happening, this is like it says, these reward distributed, submission graded, these events only happen that after something changes, right? When a change occurs. So it's good to be able to like subscribe to these events, right? And then like set up a WebSocket or some kind of service that's listening to this specific contract. But that's just a very passive way of interacting with smart contracts. It's not really doing anything itself. And that's why the functions really matter. I feel like I'm just going to close this. All right, save. What do I need to do? My keyboard's here. So the functions themselves, they're what really define the things that you can do to interact with the smart contract. I'm not even going to worry about any of these other things. We're just going to have a look straight at the actual contract. We're going to get rid of that. I'm not used to having my keyboard here now, so I'm pressing the wrong buttons. Oh, my neck. My neck is really sore, guys. So, based off these things that we've just kind of introduced a little bit, if we're building a smart contract or we're building like this learn to earn platform, what kind of things do we need to do to be able to interact or with our students and make these changes? Well, the obvious thing is register as a student, right? I need to go past this VBetterDAO stuff so we can come back to it later. The first thing is register a student, right? We need to be able to either register on behalf of students, maybe we do it that way, or we need to be able to have students basically come to our Learn to Earn platform and register themselves, like sign up for our platform, right? And that's probably a better way to do it, because we don't need someone to sit there and check every time. We can have a check, as you've already seen, using these kinds of mappings, where we can say someone's going to register, are they a student yet? You know, kind of just return that information, and we can make changes or give different outputs based on those kinds of things. Like we can say, you're already a student, you don't need to register, you just need to do your grades, right? Do your certificate. So like that's an obvious thing, right? Register a student. But we can also probably do things like update whether or not they've registered, update whether or not they've graduated, attach a certificate or validate that a certificate's been issued to them for that particular course. And we can also do things like check whether or not someone already has a record, or compare information about their address to make sure someone hasn't used the same address and tried to register multiple times. And so we need to kind of build out all these different functions to make this struct as safe as possible, right? We need to lock it down. And that's something that's really important about smart contracts. We can't have ways to manipulate these data sets, because if they can be exploited, or obviously if any app can be exploited, that's bad times, right? Bad times for the users, bad times for the developers, bad times for the team behind it and everyone involved. But when you're looking at smart contracts, this not particularly, but in general, we have problems where we're building services or deploying applications that people interact with their money, and there's a much bigger risk, right, to people's livelihoods there than saying, oh yeah, you need to change your password for your email address, right? It's a much heavier hit, I think. And so when we're building smart contracts, we always need to try and lock these things down as much as possible, so we don't accidentally leave a function public that's supposed to be private, or anything like that, right? We might allow someone to change their address, and you say, oh no, actually that's probably a bad idea, because if someone can change an address, then that means that any student or any individual who isn't even a student can just change the address of someone who has just graduated based on an event being emitted from the contract, change it to their address, and then they get awarded for it, right, rather than the student. So it's obvious, right? But I feel like I need to say it still, that these things, we need to make sure they're as tight as possible so that accidents like that don't happen. Well, accidents or not, it doesn't happen. Cool. So functions. Functions look exactly as you'd expect them to look in Solidity. You declare a function with a function keyword. I need to go back to the keyboard. Let's just put him there. You declare the name of that function, in this case add student, and then you define its parameters. I've done these on separate lines. I generally think that's a better way of looking at it. A code's supposed to be vertical, isn't it? Let's just be honest. All right, you can tell me. Code should be vertical, right, guys? But yeah, essentially we defined the parameters that are needed. In this case, really, we only need the person's name, the student's name, their first name and their surname, because everything else we can get either from the transaction or has a default value. Okay, so here this is public and it's payable. All right, and that public means that anyone can do it. And payable means that they've got to spend some money to do it as well. But basically, what we're going to do is, first off, we require a payment for registering. And you can see with this error code of this require here, oh, look, you can go back. You can't do that in Vim. So here you say, you're either requiring, if you remember, we've already kind of touched on what require does, but it requires a value in the transaction, and that's what this message stands for, this little message, right? This is the transaction that comes to the smart contract, is equal to 1 ether. Now, okay, this is something we need to talk about, right? So Solidity was written for EVM chains. It's deployed on Ethereum. That's kind of what it was built for initially. So here, 1 ether is representative of 1 VET, right? Not 1 Ethereum. All right. So we'll just cover that now as like a pre-warning, so you don't think it's incredibly expensive to be able to join this course. But if there isn't at least 1 VET in that value, or it has to be specifically equal to that VET, then it'll error out saying that you must pay 1 VET to register. Now you'll probably say, oh yeah, it would be a lot easier if we just had something like is greater than or equal to, right? But we don't. But like there are probably little things like that we'll notice as we go through that we could probably change to improve. Kind of like the public information about people's identity. Ooh, it's got bones in it. Ooh. Right. I need to mute. Sorry about that, guys. It's literally so hot in here, my voice is going. And that went right down the wrong hole too. Okay, so anyway, very, very simple. That's what's going on here. You must pay. I need to put my mouse back over here too. So the next thing, first off, they're paying, right? So that's the first check. But then we need to make sure that the student hasn't already registered. So we have this other require statement. And it says that if students doesn't have this this sender, and the sender's the address, right, of that student, this particular address that's signing the transaction, if they haven't registered, then it returns true. If it says that they have registered, then it'll just error out saying you've already registered. All right, you sneaky guy. The next thing we do, obviously, they're the 2 basic checks we need, right? It's not like we're pulling in a lot of information, but then we need to create this student record, right? We need to create this struct. And obviously we have some predefined data. You see here, we got this message.sender. And as I already mentioned a bit further up here, message.sender is just the wallet address that's sending the transaction, right? The person who's signing and that transaction. So this can be added automatically. We don't need to include it as a parameter here. We only need to include information that we can't derive from the actual transaction itself, or isn't already predefined, as is the case with registered, graduated, and certificate, right? So next we have a different function, and this function's private. And so that means that it's not just available for any person to interact with. In fact, it requires a student address here, but this private should only be interactable if there's a certain address that's actually calling it. And that's really important to be able to kind of lock off certain endpoints in our API, or like particular methods in our class, or in this case functions in our Solidity program, so that you can't necessarily just query specific data or make changes that shouldn't be publicly available. And that's why we use the private keyword. You see, it's also a view, and that's basically means that you're reading from data from the chain or from the contract. You're not making a change. So here we check our student for the student address. It checks that they're registered and then returns true. All right, that's just basically a helper function here that's just used automatically. Excuse me, I'm gonna end up coughing again in a sec. I can feel it. It's like not quite finished, you know. Okay, so next we have this submit proof. So when a student completes a course, we need to be able to validate that and or record some kind of information on chain that is used as a proof, right? You can kind of consider this, I don't know really what's a good analogy of, you're providing a transaction that's validating a certain action's been taken. So here, what we're doing is we're passing this proof, and this proof is just a string. It's not anything, yeah, it is just a string, isn't it? Yeah, I mean, it says right there. It's just a string. We check if the student in question's registered, the person submitting a proof. We check that they haven't already graduated. We check whether or not the proof exists, whether the proof's empty, right? Because it can't be empty. It starts, actually, our contract hash starts as a 0, but the proof that we're providing can't be an empty string. If it's an empty string, it's got to fail, because then obviously no proof's provided, and you don't actually need to have any kind of data passed as that proof to be able to submit, right? So you'd just be able to exploit the contract very easily. The next thing we do is we store the submission, right? So we store the proof in submissions here. And we emit this event saying the submission's been received. So actually, that's a good point. When we need to emit a specific event, we call that event, instead of defining it as an event type up here, we call it as a function here, right? And then we just provide the appropriate parameters. So here we can see, so that actually the one time that hovering's been handy, our event, which we defined just upstairs here earlier in the contract, we've got our address, which is our user, and a string, which is this proof. And what we'll do is emit event on chain that basically confirms that this has happened, right? So we have a record of that as well, like a timestamp. Okay, back to the old, back to the keyboard. So you can kind of see here how these things work. I don't know how much value there is in walking through all of these things specifically, but I mean, we can do a couple more, right? Let me know if you can't be bothered with that, guys, and we can move on to some other stuff. But I mean, we should probably cover quite a few of these, because some of them have a lot more things going on than others. For example, that checking whether a student has done a thing earlier, that just basically checks whether they registered or not and then returns true. So this one is a grade submission. So this is a public endpoint, you see here. It's got the public keyword. Oh, I've gone to the bottom and now gone to the top. Totally lost it. I'll just find it again quickly. Oh, this little map's fun, isn't it? Here we go. So our grade submission takes our address, our student address, and it takes a bool, which is either true or false based on whether or not it's been approved. We just give it the approved keyword here, like a variable name. And then we check, oh no, it's done it again. It's done it again. Grade submission here, I need to click. So that's typical, isn't it? Anyway, we require that the person who's sending this is the registrar, right? And if you remember, actually back up to the top, we define our registrar, right? They're like the person with admin access to this contract. So this particular function can only be called, here it is, by the registrar, right? This is an admin only function. Only the registrar can grade the submission. It says here is the error. Here we got checks whether the student's been registered, right? That we're passing as a variable here. And then we check that the submissions length is greater than 0, otherwise there haven't been any submissions. And then we require that it hasn't been graded. If it has, then the submission's already been graded and you can't grade it twice. Then we change that graded value in our struct to true, where it's predefined as false when it's initialized, and we emit an event saying the submission's been graded, and it gives the student address and the value approved. And then if it's approved and not rewarded, it distributes a reward. All right, that's pretty simple. Then what distribute reward does, oh, it's right here, is an internal function here. I gotta get off this mouse. It's an internal function to distribute VBeta rewards. And we've already spoken about this being integrated with the VBeta. And that's like kind of something that we're looking for, particularly as one of these submissions, one of these tracks for the hackathon. And that's where this interface comes in. And I know we talked about this earlier on the slides, but you couldn't really read it very well because there wasn't any syntax highlighting. So now we can have a look at it in a little bit more detail. And you can actually read this, right? I know you might say, oh, syntax highlighting doesn't matter. Like I say, I used to write Haskell, so I know a little bit about unhighlighted syntax. But it is much better when you can just identify things directly, right? So we've got an interface for this other smart contract, this extra earn rewards pool. We have a function called distribute reward, and it takes our app ID, which is in our constructor for our smart contract, an amount of rewards that we're distributing, the recipient or the receiver, right, which is the address of the person who's receiving these rewards, and a string, which is the proof. So this is actually what the proof's being used for, right? The proof for VBeta, because when we're submitting to VBeta, we need to be able to provide a proof, otherwise a transaction will fail. And you can see this is marked as external because obviously this is a separate contract. This isn't our contract, the extra earn rewards pool. And then we define this other function, which is available funds. And this just returns a number with the available funds for that particular app, right, for our app ID. Okay, cool, we kind of covered that. Now we can go a little bit further down back to here. Okay, distribute reward. So when we call this distribute reward function, we can't just trust that it's right. We obviously need to check some things. And the first thing that we need to check is whether or not there's enough rewards in the pool. And so here the first check is our reward amount, and it says, is the reward amount greater than 0? Because you need to be able to actually distribute some rewards. If there isn't anything there, then you can't. Then the next thing is we check that the reward amount is less than or equal to the available funds in the contract, with our ID being passed as a parameter, which is this available funds function that we call from that interface, right? I don't know if I can just, is it control click? No, it's not. It's up here, available funds here. And then I thought there should be some highlighting down here as well. Oh, lucky guess. So yeah, so obviously we need to check using our app ID to see if our app actually has any rewards to distribute, because again, if we don't, or if we have less than is required to be able to reward the user, then we obviously can't reward them, right? We can't reward more than is available in the pool. So then we mark this particular student as rewarded, which you can see here prevents people from withdrawing rewards multiple times. So obviously that's quite an important thing for us to do, right? And we create a proof, which takes the ABI, it's got some bit of information, it adds in the student address and the institute, right? So it's specific information to this contract and this call, and then it provides that as the distribute rewards proof here, all right? So, oh, and then the very last thing is it emits an event, and that event is the reward distributed event. If we go over here, this is another one of these events that we defined earlier, so we can highlight this. Reward distributed takes an address, takes an amount, and you can see it's been well written, guys. We got clear variable names, right? So it's easy to kind of understand. Okay. So this function issue certificate here is quite a simple one, but there's a lot of things going on, right? It's easy to say, oh, issue a certificate. Yeah, when someone's submitted a proof, or they've registered and they've been graded, then we just issue a certificate. But we need to make sure that certain information is in place, so that people can't just write their own certificates, right? Obviously, so we need to have all our checks in place to be able to actually allow this endpoint to be public. And what we want to do First, we just check that the person who's issuing a certificate is the admin, right? The registrar, the person with admin rights, essentially, for this contract. If not, it says only the registrar can issue. Then we check, we use our check student function, which, if you remember, is a private function we had earlier, which is it can be hinted at by this little prefixed underscore, by the way. We check our student address and we say, have they already graduated? First, we obviously get the student data. Then we check if the submission's been graded. Then we create a certificate, which we just basically generate a hash. And then we update student.graduated to true. So we record on chain on that individual that they have been issued a certificate as well. And you only get that graduated to true if you've issued a certificate, right? It happens afterwards. So it can't happen, it doesn't happen accidentally before and prevent someone else from being able to, well, prevent a student from being able to get their certificate. And then obviously we're going to emit an event. I feel like we kind of got in the flow of emitting these events now, so we expect them a little bit more. We just emit this certificate issued event. We give a couple of bits of data, the institute, the certificate itself, and the student's wallet address. Cool. We've got about 50 more lines of this, but they're all pretty simple now. We just have a bunch of little functions to check certain values without making any major changes. So the first one is to check if a student's graduated, obviously a useful helper function, and it's public, it's a view, so it's not costing anything, it's not requiring a transaction. Then we check again for a student submission, get submission, we pass an address, and we get some submission. Check if a submission's been graded, again pass a student address, and it returns whether or not it's graded. It'll be true or false. The same with rewarded. And then we have this other one, which is get available funds. This is going to check the pool, our rewards pool in the rewards contract for available funds, right? The helper function that we were having a look at in this interface, which just takes our app ID and returns a number, right? So that we can check at any point if there are actually any rewards in our pool. The last one, or the third to last, is set a reward amount. Obviously, we don't want anyone to be able to set the rewards amount that we give for any kind of successfully graded submission, you know, some certificate. So we force that this is only signed by the registrar. I feel like that's kind of obvious, right? We don't want anyone else to be able to do it. We also check that the amount is greater than 0, and that's about it, really. The rewarded amount is equal to that amount. We can't pass an amount that's less than 0 because, like, obviously you can't distribute less than 0. I feel like that's kind of obvious, right? But it also probably needs to be said. So we got 2 more. We got an update for our app ID. Now, this is set in the constructor, right? Our app ID is set in the constructor. So when we deploy our contract, we need to provide that app ID, if you remember. Where is our constructor? Probably above here, probably below here. I feel like that's in the wrong place, isn't it? But we need to pass this app ID. But here we can actually change it, or we can update that value. And it can only be done by the registrar, right? The person with admin access to our smart contract. And it just changes the app ID to the new app ID. And the other thing we've got is withdraw balance. So I don't know if you remember, because I honestly have no idea what the time is. I've got no idea how long I've been talking through this smart contract. But right near the beginning, we said that it's going to cost a student 1 vet to be able to register, right? Where we had our registering our student, I think it was about here. Yeah, here. So you must pay 1 vet to register, right? And it checks that 1 vet is being supplied. So we want to be able to, at some point, withdraw all of these submission payments, right? So when people register, we want to be able to withdraw the balance. And you can see here the comment registrar can withdraw collected vet from student registrations. All right. And I mean, you can kind of imagine what goes on here. We check that the sender is the registrar. We check what the balance is, the balance at this address. If the balance is greater than 0, then it will continue. It checks that it's payable to the registrar, so they're receiving it, and that balance is the value that's being sent. And then it requires a successful transaction, like a successful submission. All right. But that's it, right? That's the whole. I can't believe we've actually got through the whole contract. That's actually blown my mind a little bit. When I was talking to students about this, we did not get all the way through this contract, but we did talk about quite a lot of things aside from this. Now, the next thing really, once you've written your contract, is to compile it, and we talked a little bit about what this command would look like. Actually, this is a good point. I'm glad I opened this up, because compiling it is really the last thing that you want to do with a smart contract. The thing that you want to do between writing and compiling is writing tests. Now, I need a bit of water, but you might not be that excited about writing tests, and I understand it. You know, you might not enjoy writing tests too much, but you need to make sure that your contract functions correctly, right? That is really important. Again, like I already mentioned, you're dealing a lot of the times with people's money, and you owe it to them to make sure your thing functions correctly, because it's not just you who lose money or vet or better tokens or anything if there's a problem with your contract. So it's really, really important that you have tests that are able to fully validate whether or not your smart contract functions as expected. And not only that, but you can actually check for specific edge cases where things might change, or might change how the contract acts, that you can't kind of preempt, right? And that's also really important. I think I can execute it down here. All right, we got Ghosty. Now this is a familiar interface. You know what I got to do actually? Guys, if any of you have any questions, I need to change this so it's not like transparent. So while I do this, if you guys have any questions, pop them in the chat. I'm happy to answer anything as best I can. And oh, I've lost it. I've lost my terminal. Here we go. Okay. And while I do this, you guys feel free to pop any questions or anything in the chat that you have. I need to just change my config quickly. I should have done this earlier and I completely forgot about it. Guys, do you work with like cursor and VS Code, or do you use like a terminal editor or something for writing your code? It's interesting to find out about that kind of stuff, because a lot of people complain about them at the same time, and I was actually like that for quite a while, and then I got sick of being told what to do by AI. It's here, isn't it? Yes. Then what do we want to do? We want to okay, cool. So now we're going to sort out our terminal and we can actually execute this. All right. Ghosty, reload configuration. Oh, wrong button. But okay, so actually while I'm doing this, let's talk about this. So there is a test suite built into Hardhat, and Hardhat, like I said, is like a development environment that you can deploy very easy with VeChain, and you can set up your Hardhat environment specifically for writing your smart contracts with a ton of stuff built in. But we haven't used it in this example because we've kind of gone a little bit more minimal with our setup. And what we've got instead is we're using Foundry, which is like a very popular Solidity development tool, to write our tests. And in here we've got a huge file of tests that basically, I mean, I don't actually know how long it is. I'm interested now. Oh, it's only about 50% larger than the actual contract. But what we do here is we actually test all of the different functionality and all of the different contract calls within our smart contract so that we can make sure things function correctly. Now, if I go over here, I need to zoom in. I need to zoom in, don't I? Big time. Let's just go, where are we? We're going to go here. I'm terrible at writing on QWERTY. What is it? It's learn to earn. Hopefully that's the right place. Ah, it's not. CD learn to earn. Sorry guys, this isn't very interesting for you right now. I appreciate that. But what we want to do is, if I pull this over, is just execute. And because this, like, I don't know what it is exactly, like exactly why it doesn't like it, but cursor, for whatever reason, doesn't like execute in the test. What is the test called? Test runner. So if we say bash test, test runner, what am I doing? What it'll do is it'll just run all of these tests. You know what I've got to do? I've got to change the, I've uncommented a bunch of the old, code, haven't I? Let's go back here. We're going to skip through all of these now. That's frustrating. But what we have here, we've got basically, when we're writing our test, we've got the same setup. We've got our MIT license, we've got our pragma defined. We're importing different things. So we're importing this test module, we're importing our contract code. And then we're basically just defining different different functions that are used to check. Get our reward call, we've got our learn to earn, and it's defined as a test here, you can see. And then we set some values, so we're using just like 1 as our address, 2, 3, and 4. We're checking our rewards amounts. We got a function for setup or deploying. We got a test deployment, test student registration, and a ton of other tests. All right, so there's loads of stuff going on. Tests aren't that exciting. All right, they're actually really boring, but they're so important. And what I recommend you do actually is just have a look through this, and if you have access, I mean, you just run the quick start script in get VeChain. Sorry, what is it? npm create VeChain dApp, and with that you can look through the hard hat stuff, and it'll show you that stuff. Oh, I didn't uncomment the things. I need to stop talking, guys. We'll just comment that out. Comment that out. Comment that out. That's already done. What else do we have here? Nope. I don't think we have anything else. I think that's probably about it. Let's go here. Let's run that again. Okay. So Foundry is quite, let me actually zoom out. It's quite a nice little test suite because it has some kind of terminal output, and terminal outputs are always nice. It's very similar to like how you would expect Jest to work or something like that if you were writing JavaScript or TypeScript tests or whatever. But what we do have here is like a gas estimation as well. So how much it's costing to run these things too. And that's really useful, especially when we're like compiling. You can have gas estimations as like a flag that you can use when you're compiling your smart contracts too. And it's really handy to know like how much these functions are costing, because it's an opportunity straight up to be able to start thinking about optimizations that you can do, or give you a rough idea for how many of these you can bundle into like a single block or a single transaction based on those limits. But it gives you a nice little table that it prints out. So we've got 20 past tests. We got 1.38 milliseconds of CPU time, apparently. That's pretty quick. And you got you see this university original sol. This is like the initial draft version of the contract that we started with when we were building this example out. You can see here we don't have perfect test coverage. Our branches aren't exactly completely covered, but it's just an example of how this thing works. It gives us a little test summary at the end, but that's just logged from the script, right? You take that with a pinch of salt. All right. In fact, I'll show you. If we have a little look at that file, our test run a script, we're just printing these things out here, right? So the test summary is not like a perfect, yeah, just because it comes in the thing doesn't mean that it's actually, that's not output by the tests at all. So that's important to note as well. It's not just reading this stuff magically and printing it out for you. But the contract is ready for deployment, and that's kind of what's important. But yeah, I would personally, I would take some time to actually look through the tests and look through the tests in the hard hat deployment tooling as well that we have on VeChain. They're done differently, but not that differently that you can't just understand them by looking at them. And running them as well is obviously a good way to get your head around things too, or trying to change values. The good thing about tests is you can afford to change values, right? So that's good. The last thing we need to think about is compiling. Now, we had a little command earlier, but I don't actually know if I have a command here. Let's have a little look. I don't think we have our, no, we don't have our history here. Okay, so we'll kill the terminal. We'll switch back to Ghosty. And actually, we can have a look at what did we put our folder as. All right, cool. Let's just do it like this. We're gonna put this over here. We're gonna put this over here. So we need it. We need the output. Oh, actually, we've already compiled it. We've already compiled them. So we can just have a look here. Yeah. And get rid of that. And we'll pull this up. So in our example earlier, if I pull this up, we had some commands for compiling contract, right, with solc. Now, obviously, we've just replaced here buymeacoffee.sol with learn-to-earn.sol, and we haven't output the metadata, and we're not sending it to out. We're sending it to compiled/learn-to-earn, right? I think that was what it was. Let me just minimize this and get rid of it. Compiled/learn-to-earn, right? Yes. So in here, we've got our binary here, which is the compiled code for our smart contract. And the other thing, which is probably going to be more usable for you in your apps, is the ABI. And I don't know if you remember, right at the beginning, we were talking about this binary output and this ABI output, but essentially our ABI is a list, right? It's a list of objects that define interactions that you have. And when we look through this, we'll be able to kind of figure out what these functions are as well. So here we've got some internal types. We've got some, I tell you what, let's find something here. Minimize that one. Anonymous false, inputs. Let's not worry about that. I'm looking for something with some clearly defined types that we can work with. This one's name is reward distributed, right? So if we have a little look at learn to earn sol, we've got our rewards distributed, which is one of these events here, right? And so we can clearly see that this bit of this ABI, this object here, is referencing this event, and this is the function name that it's called, right? And then you can use these as the definitions for clauses. So when you're running particular actions on VeChain, instead of adding all of a smart contract, right, and only being able to execute one per transaction, VeChain has some extra features which mean you can just call specific functions directly, and you can bundle them into transactions as well. So you're not limited to just a single one like you are on some other EVM chains. So on VeChain, we interact with smart contracts as clauses, right? We take a clause or one particular function or method from our contract, and we just execute that one bit of code. And this is, generally speaking, this is what you'll be using with like the VeChain SDK in order to actually execute those things, right? And actually I might, maybe we have like a little example of that we can have a look at. Wait, let me just check over here. Sorry, I'm trying to find an example. Guys, if you okay, so we do actually have a question here. What's the difference between uint256 and bytes32? So bytes32 is a 32-bit hash, right? So that represents like the proof that we're generating, whereas a uint is an unsigned integer. So they're like completely different types of data that are even supplied. All right, so that's kind of it really. Sorry, I'm trying to find this thing for us, guys. I don't have it to hand. But basically, what we do when we're trying to call different bits of functions is we can pick like a single clause or a single one of these little functions in our smart contract and just execute that by itself. Or we can bundle them and execute several of them, or we can include several of these things together from different contracts in a single transaction too. And that's one of the like cool things that VeChain can do specifically, which makes interacting with smart contracts a little bit easier and a little bit smoother, and it gives you a lot more flexibility with the kinds of things that you can do as well. All right. I mean, I don't really. I think we're basically at the end of it here, guys. What's the time? It's 22. Okay, so we got a few minutes left. If you guys have any other questions, I'm actually just going to have a little scroll up here and see what else we got. Okay, someone's got slightly unrelated, but it's about just interacting with things on chain. So if, for example, like we got someone asked a question here, they want to get involved with the different kind of products and apps. Don't know where to start with VBeta or Stargate. The current VeChain can be transferred from my current wallet to VBeta or Stargate. Yeah, basically, right. So Stargate is like a staking platform, and so you basically that's what it's for. VBeta, on the other hand, is like it's a platform for people to distribute rewards for different apps, basically. So they launch apps on VBeta, and you can just go there to one of those apps and connect your wallet and interact with those apps. You don't need to like interact with VBeta specifically. It's just a kind of platform that aggregates these things and has these reward distributions for these different apps. So for example, there are a ton of apps on VBeta, and a mixture of web apps and mobile apps that you can just download or join, basically. You can join with your wallet, with your native wallet, or you can join with, a lot of them have like social login, which is a really, really cool feature that's kind of used, it's almost forgotten about on VeChain in my experience, because it's just so normalized on VeChain, but on other chains it's like quite huge, right, having social login as an option. But a lot of the times people just have their social login for their VBeta apps and not their wallet, and that generates a wallet for them that they can then use to interact with that application. So you don't really need to transfer anything. You just go to like one of the VBeta apps, you know, whatever, like literally any of them, like mugshots, the first one that comes to mind, probably like the largest, but yeah, you can just get their app, use their app, and earn rewards using social login, and then transfer those rewards to your main wallet or whatever, right? You don't necessarily need to transfer stuff to VBeta to be able to interact with that ecosystem. Quite the opposite, in fact. You want to do less interactions with VBeta and just focus on like taking part in the ecosystem to earn rewards. What you can do with VBeta is interact with the ecosystem through their platform. So for example, they have voting rounds where you can endorse certain apps to be able to get rewards distributed, because there's obviously like a finite amount that you can do, right? So people endorse these apps, the ones that have the most endorsement, or up to a certain threshold. If you have more endorsement than a given threshold, which is like 100, I believe, then you're able to interact with those apps and earn rewards through them, and they get distributed rewards for that period of time, and other apps won't. So there's this thing with VBeta, which I think is really, really cool, and that's that if your app is servicing people, like people are using your app and they're enjoying it and they're earning rewards for the actions they're taking, then you'll stay in that circulation. But if you're doing, or if it's found out that you're not having the appropriate protection against farming activity or something like that, then the community will vote you out. And so one of the amazing things about VBeta is it has this very kind of organic community interaction of people voting in apps, kind of giving them a try new apps to the ecosystem. And then if they're good, if they're doing well by the community, if they're kind of combating farming on their platform, then they stay in circulation. And if it's found out that they're not really doing the steps that need to be taken for those kinds of actions, then they get voted out. And yeah, it's a really cool ecosystem. A lot of different blockchains, or a lot of people have talked about DAOs and implementing like DAOs, and VeChain is one of those places that has as one of the key things that we're really focused on. And actually us in the hackathon, we're looking for one of our tracks is to have people submit apps to VBeta DAO, right? Build applications for this platform. And it's a really good example of a real life implementation of a DAO that allows people to interact with the blockchain and benefit from the immutability of blockchain and the decentralization of blockchain without necessarily needing to know what blockchain is. It's not like you need to worry about having your app and knowing about how you deal with your wallet, your app. I said app so many times. You don't need to have to worry about things like dealing with your private keys or like cold storage and stuff like that. You can just download the apps or go to their websites, sign in with like social login, and start interacting with the blockchain. It's a really good way for like people who aren't exposed to blockchain to be able to dip their toes in and start to have that experience, and start to actually have a reason to learn, but do so in a way that's kind of incremental and easy to get involved with. A little bit of a tail off there, but I think it was worth talking about that question because it was a good one. Yeah, I mean, guys, the main point of this workshop is to introduce these concepts of Solidity, writing smart contracts on VeChain. We've gone through it, and I know I've kind of whizzed through it probably a little bit quicker than I should have. I'm trying to think if there's anything that I didn't touch on that was probably good too. I don't really think so, to be honest with you. We kind of whizzed through everything. Yeah, I don't really think so. Oh, actually, you know what? Right, so right when we first started looking at the contracts, I was talking about the oh, what have I done? No. Oh, silly old interface. So we talked a little bit about the these two values here, right? The personal information being stored on chain. Now, I don't really think that this is a good idea, and maybe you would argue for it, right? I need a little swig. Right, we're going to have to finish up soon, guys, because I'm out of water. Maybe you'd be able to argue that there is a good reason to have this information stored, but it would be publicly available, and it would be publicly available like as strings, right? It's not like you could even just kind of obfuscate this data slightly, because realistically it's not really used anywhere else, right? Let's look for let's see where our students being used. We're not really using we're looking at our student through the wallet, but we're not really interacting with it in any other way. I'm going to just try and scroll through and see if we can find it. Registered address. address, address. The only thing that I could really think is maybe in the certificate. But even here, we got the address, we've got graded, certificate and wallet, right? Are we passing anything to the certificate? The timestamp and the wallet. So like we're not even using it, right? So why are we storing that stuff on chain? I think it would be better if we needed to have that record, right, of an individual's name. We could do something instead to kind of obfuscate it so that you couldn't just query that and just find it on chain and get people's personal information, because that is a huge potential risk, right? To just expose people's private information, right? So how could we do it differently? Like what could we do? Well, I mean, first off, we could just not have it, right? We could just say, oh, yeah, we don't need their first name and surname. Like we're not using it, so get rid. You know, but what if there was a reason that you want to do it, that you wanted to keep it? Well, maybe you just put a like you kind of hash that data. You know, maybe you put a 32-bit. You just use this type instead of string, and you just generate like a hash of both of these values, right? And you just put the identifier, like some kind of name hash or whatever. Call it whatever you want. It doesn't matter. You know, and then it would mean that it's like a one-way validation. But if someone is coming, like a student, when it comes to actually demonstrating that, you can always call that function again and prove that your first name and surname comes up with the same hash, right? Maybe that would be a better way to do it potentially. Or, I mean, realistically, personally, my opinion generally of storing data on chain is the less the better. So I would really just say like no need for it, right? But that's my opinion. You might have a different opinion, right? And that's cool, you might. But what I wouldn't really do is just put it on chain like that in that state, right? Just a string that says your first and last name, especially as that identifies your wallet too. I think like wallets are the identifiers on chain, and that kind of an extra little element of privacy is like really good, especially on something that's always publicly available, like as a record. And it doesn't really change the functionality of the contract. So protect people who are using your apps as well. Don't just start putting their personal information anywhere. Yeah, I mean, I can't really see any reason to actually have that. Ultimately, when you get your certificate, it's going to have your wallet anyway, right? It's going to have your wallet. So it's only like all this information is going to be tied to you, because you can just sign a transaction to validate it, right? To interact with some other ecosystem, or, you know, maybe we mint like a certificate as an NFT instead of just issuing or emitting some event on chain. Maybe we issue like an actual certificate, an NFT. Yeah, that can have your wallet, that can have some other information instead. It can have the address of the student. So even if it's transferred, you can make them non-transferable, but even if it is transferred, it's still identifiable as only one specific person. So if the wrong person's owning it, then it's invalid, you know, and you can validate those kinds of things anyway on chain. So I would get rid of people's personal data, to be honest. I would really kind of avoid it at all costs. Yeah. It's a minor thing, right, guys? It really is a minor thing. It's just something to consider when you're writing these things for yourself. Because, oh, what am I doing? Double clicking. Go away. Because it's very easy to kind of think, oh yeah, we need to store this information. And if it was a database, like some private database, it's not really as much of a big deal. But the issue is that it's public and that anyone can query it. And that's when it becomes risky, right? Normally your database is like protected and it's not exposed to the public. It's not like the yellow pages or something. But yeah, that's one thing that I would probably change to improve it. But I mean, guys, that's it. So I'm just going to kind of end it here, I guess. I'm just going to end it. That's the end of this workshop, guys. Let me pull this back up again. There you can register. Where do we have it? Where do we have joining? We had some information somewhere. Yeah, this is it. Right. So you can register for the hackathon. You can find out the terms and conditions and stuff all through academy.vchain.org. Sorry, I said register, but you can't technically register yet, I don't think. Or when the registration page comes up, I think we might have like an early bird registration actually, now that I've said it out loud a couple of times. But you can go and you can check out the description of this video, and what I'll do is I'll make sure that it's updated with that information so that when we do have our registration page up, or whatever kind of pre-registration page or information we have will be in the description here. It's not currently, all right? Sorry about that. But any questions you have, put them in, go to VeChain Builders, right, and join the Telegram, or go to the VeChain Discord in the developer section, pop them in there. Anything that we can do to help you guys out with learning or trying to understand or get your head around some things, feel free to pop it in. I feel like I've been just talking continuously for like 2 hours now, and my voice sounds like, I feel like I haven't recovered from that little cough, to be honest. In the next workshop, we're going to be having a look at kind of back-end stuff. We're going to be looking at specifically the VeChain SDK. We're going to be looking at all the tooling that's part of the SDK. We're going to do reading, writing, subscribing to events, like building transactions, interacting with smart contracts, like specifically using this one that we've worked through today and that we've looked at. So we can start building out this application more, right? And we can have this learn to earn platform ready to deploy to vBetaDAO in a couple of weeks in the vBetaDAO workshop. And actually, because I haven't really talked about it, the order that we're going to do over the next couple of weeks, these live streams, we've got the Solidity one, which we've just done. Then we're going to have back-end, like VeChain's kind of back-end tooling, like the SDK. And then we're going to have front-end stuff, which is going to be like connecting your wallet to a front end, using it to sign transactions and certificates and stuff. Then we're going to have a look at the vBeta integration. So it'll be taking like this smart contract and this app that we've built, and we'll be learning how we can apply and submit it to vBeta to be included in their applications and join the DAO, right? And then the final, sorry, it's not the final one. Then we're going to have the one chain for cross-chain tooling, which is again one of the tracks in the hackathon, and it's gonna be a really big one. I think there's lots of opportunity for this kind of interoperability, the track as well, and so it'll be really interesting to see how they do the workshop and like the kinds of tools that they've got available. And then finally we'll have like a full stack example where we kind of go take everything that we've done so far and kind of build it all together and go through the full process in like one go. And this is going to be as much of like a Q&A session as it is like a demonstration, where we'll have already built all these bits, you know, and we're really just sticking them all together, and it's a really good opportunity to be able to demonstrate things and answer more questions in like a more of a kind of natural and organic way, whereas here we've kind of separated them a little bit. So that will definitely be one to watch, I think. And even if you miss any of these live streams, by the way, obviously you can just catch up with them in a day or two or later on in the evening if you're at work. But we're going to try and stick with around this time frame, except for the initial vBeta one, which I think we're going to be doing on Singapore time. All right, guys, thanks for joining. Thanks for coming and checking it out. If you got any questions or comments or anything, pop it just below. Don't forget to subscribe to VeChain Official. Subscribe to the YouTube channel. We're going to be having a ton more of these things coming out. Definitely join the other workshops. Just make sure you hit the bell. Do they still have the bell on YouTube for notifications? I can't tell. But if they still do, I have no idea. If they still do, hit the bell so that you know when we go live next time. It'll be the same time next week, but still, just so you get reminded about that. Join us for the back-end workshop as well, and I'll see you then. Cheers.